functions. We're about to move into your exponential and logarithmic functions. Before we do that, we're going to go down memory lane and refresh your memory about the laws of exponents. You guys are going to, again, not so much be learning, but just refreshing your memory on how to simplify expressions using those laws of exponents. We did it right at the beginning of this unit back in December. When you guys had the packet, it was a part of that packet originally. Okay, and so you should be aware of the properties. You should remember the properties. They are also covered on the SAT and the ACT, so it's very good to know them. I'm just going to give you, though, a few more examples, I guess higher thinking examples, some of the types of problems that maybe IB could potentially give you. That's why the examples part of the foldable is blank, because we're going to be filling those examples in with a few IB problems, and then depending on how much time we have left, we'll do some whiteboard practice as well. Okay? So here are your different laws of exponents. You have power rule, product rule, quotient rule, zero exponent rule, and so on and so forth. Okay? If you lined up your foldable correctly, then the correct rule will go with that particular part once you look at the tab. Okay? When you look at the rule part of the foldable, you'll see the different rules. All of these, again, they are refreshing your memory, okay? They haven't changed. They are still the same, okay? When you're looking at that zero, the zero property, okay? Remember, anything to the zero power is always 1. And just be aware of the exponent, which base that it applies to, okay? Because there's a big difference between x to the 0 power, and then like 7x to the 0 power. What does that simplify down to be? 7. That is 7, because that's nothing but 7 times 1. 7 times 1 is just 7. Okay, so do be aware of whatever the exponent, whatever the base is for that exponent, that's what it applies to. Okay, if you look up here, I believe this one is the power of a product rule. This one here, the exponent applies to both pieces on the inside of the function, the inside of the parentheses. Okay, so just be aware of what the exponent is applying to. Your product rule or power to a power rule, you multiply. Your product rule, whenever you have the same base and you're multiplying, you add your exponents. Your quotient rule, when you're dividing, you subtract. You guys remember this? Okay, with the fractions. Okay. The power applies to both the numerator and denominator, so on and so forth. Okay? Let's take a look at a few examples, okay? I know they might be kind of small. I'm trying to make sure they fit inside of this diagram here, okay? But let's start with your power of a product rule, okay? Right here to the top, at top left. Okay, your power of a product rule. Make sure you have 3x, that quantity being raised to the third power, as your example inside of this piece, inside of this tab. Okay, so that's 3x all raised to the third power. Remember, when you apply that rule, that means you're going to cube not only the x but also the 3 as well. Okay, it applies to both pieces inside the parentheses. What's 3 cubes? It's 27, and then you'll just have x cubed. So then your final answer will be 27 x cubed. Okay? Let's go in a counterclockwise fashion. Okay, let's head over down to the power rule. That is a negative 3a squared raised to the 4th power. 3a squared raised to the 4th power. Okay? This actually incorporates the power of a product rule and power rule at the same time. Okay? That 4th power is going to apply to that negative 3. So you have negative 3 to the 4th power, a squared to the 4th power. What's negative 3 to the 4th power? Yes.
Something 81. I'm not sure if it's negative or positive.
Okay. So it is. The number is 81. Is it positive or negative?
Positive.
It's going to be positive. Anytime you raise a negative number to an even power, it always becomes positive, okay? Because you basically have a negative times a negative times a negative times a negative. These two make a positive. These two make a positive. Hence why it's positive. Then over here, You apply your power rule. A squared raised to the 4th power is a to the 8th power. Very good. Continue around in the counterclockwise fashion. We have your negative exponent rule. Now, this question is a little bit different. Instead of just giving you an expression that has a negative power and you write it with a positive exponent, I'm asking you to write this without a fraction. This is 1 over 2 raised to the 1 minus n power. 1 over 2 raised to the 1 minus n power. The question is asking us to write it without a fraction, which means that I cannot have a 2 in my denominator. So then to get that 2 with this exponent out of the denominator, we don't multiply, we would negate your exponent and bring it to the top. Okay? Remember that negative exponent rule, if you have a base raised to a negative exponent was 1 over that base to the positive exponent, it works the other way as well. If you have this, you can bring it up to the top to make it positive. Here, I need to get rid of this denominator. Since my exponent is already positive, the only way to bring it up is to make it what? It's to make it negative. So then you'll have 1 times, which will just be whatever it is, 2 to the negative 1 minus n as your power. So this fraction here equals 2 raised to the negative 1 minus n. Then I can continue to simplify that to get what? Very good. 2 to the negative 1 plus n power. And that will be how you write that fraction as a not fraction. Questions on those 3 so far? Continuing again in the counterclockwise fashion, you have your 0 exponent rule. Again, anything to the 0 power is always, like in this case, you have 7 to the 0 power, which is 1. Continuing forward, your quotient rule. Okay? Your quotient rule. Your quotient rule says when you have your bases and they're being divided, what do you do to your exponents? You subtract. Okay? But the only way to be able to do this, to subtract your exponents, are if the bases are the same. You see in the rule how it's x over x? That's the only way that you can apply that rule, is the bases are the same. So for the example that we have for your quotient rule, it says express in exponent form with a prime base. We have the division of 3 to the x power all over 9 to the y power. 3 to the x power all over 9 to the y power. I would be able to use that quotient rule if the bases were the same. They're not the same yet. Is there a way I could write one of these bases either in the numerator or denominator so that they're the same, so that I could use that rule? Yes. How so? Is there a way I could rewrite one of these bases so that it looks like the other base?
Like, are we talking about like taking away one of the exponents, or?
No, not even talking about the exponent shit. I'm just talking about the bases.
By the so like 9 times 3 and 3 times 9.
So wait, say that again.
Times the bottom by 3, the top by 9.
I wouldn't be able to do that. Could these two have the same base? They can.
Turn
9 into a 3 with a square.
Yes.
That's why I say square can be.
Squaring 9 gives me 81. You see what I'm saying?
Square root done.
But even still, when you square root it, it's like you're trying. That's another property. You would square root both sides. You see what I'm saying? But if you rewrite 9 as 3 to the second power, now don't they have the same base?
Mm-hmm.
What happens to the y? Yes. What happens to the y? What do you do with the y? And the 2? You're right. You would multiply them because that would be your power rule. Okay? So you have 3 to the x all over 3 to the 2y. Now that they're the same base, could I apply the quotient rule?
Yes.
And then what would you do to your exponents?
Subtract them.
So then this becomes 3 to the x minus 2y. And then that is how you express this expression in exponent form with a prime base. What does prime mean?
You can only get it when you multiply 1
One in itself. Okay? Questions. Being able to identify bases or numbers to where you can have a similar base is going to be a very good skill. 3 to the second power is 9. I could have given you a similar problem, and I could have said, okay, what about 4 to the 3x over 64 to the 2y? And I ask you to do the same thing. This would be an additional example. Get to where I have a prime base.
We have 4 cubed times 2y. So that would be 4 to the power of 6y.
That's the denominator. Mm-hmm. Now my question is for a prime number. No. So how could I rewrite these bases now so that they could have a prime number? So I could do 2 to the second power for both the top and the bottom. What do you do with those exponents? After you multiply, probably. Okay, so then that'd be 2 to the what power?
6x.
Over 2 to the...
12.
And then we could subtract it from there to get our final answer of 2 to the... There we go. Questions?
And then if you can't, like if the numerator and denominator can't like be simplified to the same base, like
Then you wouldn't have a problem where they would ask you to do that. Like they should be able to be simplified to where you could do that. All right, let's finish up the last two. We're now at product rule. Simple enough. When you multiply, what do you do to the bases? You add them. What do you do to the coefficients, though?
Multiply.
You multiply. So this becomes,
8x. I can't read exponents.
we have 3 and 6, so that becomes 9. So this is 4x to the third times 2x to the 6th. 4x to the third times 2x to the 6th. That bolder x is your binary x. Trying to get away from the multiplication dot, because that's used for something else. So trying to use the binary x. And the last one, power of a quotient rule. Okay? Remember, anytime that you have an exponent on the outside of a fraction, you want to raise both the numerator and denominator to that exponent. That is a negative on the outside. That is a negative. So that means that after you apply the cube, you need to make the fraction negative. So that means the 2 gets raised to the third power, the a squared gets raised to the third power, and the b gets raised to the third power. So when I simplify this, what's 2 to the third power? 8. What about a squared to the third power? A to the sixth, and then that'll all be over b to the third power, and because it was a negative on the outside, that entire fraction becomes negative. Questions on your laws of exponents? You're writing these without negative exponents, okay? And of course, you want to make sure that you simplify as well, because these aren't, like in this particular case for A, you do have a number involved as well. Whenever you have a negative, which you can't have, how do you make a positive? You turn into a fraction. I probably would have suggested to take care of that negative first, because I saw on a few of your desks that you forgot to take care of it later, okay? That negative means you need to make that entire 2c to the third, all of that needs to go under 1. Like you turn it into a fraction, so then that way you can make it a positive. And then you apply the fourth power to everything on the inside. Of course, 1 to the fourth power is just 1, but then you apply that 4 to the 2 and to the c to the third power. So then your final answer should be 1 over 16c to the 12th power.
Can you use the negative 4 first and apply to all of them and then put it over 1?
You can. And some of you guys did that, but some of you guys forgot that the 16 needed to be on the denominator as well. So you need just to be careful if you are going to apply that you don't lose the negative once you do that. Okay? Now over here, one way that you could tackle this problem is how? Flipping everything.
Or except the b2 behind.
Okay? So the b squared doesn't have a negative, so it can stay there, but that a to the negative third power needs to go to the denominator. And then that c to the negative 1 power needs to go to the numerator. So then your answer should be cb squared over a to the third. Yes?